So, good afternoon all. Welcome to the last session of day 3. I am Professor Baladar, Assistant Professor Mechanical Engineering Department. Would like to welcome you all. I would like to ask Dr. Ajit James to introduce our session expert. Over to Ajit James, sir.
Good afternoon to all of you. It's my great pleasure to welcome and introduce Dr. Sudhir Gupte, who is the speaker for the next section. Dr. Sudhir Gupte is a graduate mechanical engineer from MS University, Baroda, and he did his post-graduation from VJTI, Bombay, and he did his PhD from Sardar Patel University, Vallabh Vidyanagar. He started with his career with the Design and Development Department of Premier Automobiles, and later he worked with several prestigious automobile industries like Hindustan Motors, Telco, and JCBA. So after a stint of almost 25 years in automobile industry, he joined academics as the professor and head of automobile engineering department, ADIT Patel Institute of Technology in the year 2002, and served the institute for almost 17 years. During his career in the industry, he visited countries like Japan and America as a part of his training and project. And after joining academics, he has contributed a lot for the development of this automobile engineering department and branch in ADIT Patel Institute. We are proud enough to say that in the entire Gujarat state, we were the first to start the automobile engineering branch in Gujarat, and later even the government institutions also followed us later. So somewhere or other we can say that we were the pioneers in starting that branch, and in that Gupta sir played a pivotal role in setting up this. Even many other institutions came down to our institute to see the lab and see the curriculum and for the development of the department. And he has initiated the SAE activities in the institute, and still now also he is largely associated with SAE activities. Some of the activities include he was the managing committee member of SAE India in 2010-11, 12-13 and 16-18. He was the chair engineering education board of SAE in 2010-11. He was convener of Supra SAE India 2011, convener of Virtual Baha in 2015, convener of Baha 2015, and chief advisor of Supra SAE India 2017, and convener of eBaha. Apart from that, for his larger contribution towards the SAE activities, he has been awarded with the prestigious Guru Award in 2016 by SAE India. And apart from this SAE activities, he is into the syllabus committee and academic council of Sardar Patel University and Gujarat Technological University, and he is academic advisory council member of prestigious institutions like Vellore Institute of Technology, ARII, and ADIT. So with this, I welcome Dr. Sudhir Gupte sir for sharing his expertise.
Thank you. Thank you, Ajit. Thank you for the introduction. Uh, my screen is visible now and I am audible.
Yes, visible and audible.
Okay. Is that clear now?
Yes, sir.
Okay. So, good afternoon, everybody. I thank Dr. Sanjay Patel, Dr. Ajit, Professor Yagnesh Gambawa and Baladat for inviting me for this second session during this FDP. And this is going to be my third presentation or expert lecture at ADIT after my retirement. I thank all of them for inviting me once again. So, once again, I will start with the caption: if you take care of nature, nature will take care of you, because alternate fuels subject is all about taking care of nature. So my topic for discussion today is hybrid electric vehicles and its challenges. I will be discussing initially in the beginning about my research project on conversion of existing diesel car into hybrid electric car. After my PhD presentation, I have not done it ever so far, and this is the first time I'll be doing it for such a big mass, people in numbers. Thereafter, I'll talk about automobile market, because that is what will sensitize you as to what kind of scope and opportunities lying in EV and HEV for the future, as well as converting the existing vehicles into hybrid electric vehicles. I will talk about EV numbers sold in the month of December, as well as EV, HEV, the course for 2030, what world is talking about, how much is the volume they are projecting. Then I will talk about the recent news, again in context with the AV, HEV in India as well as globally. And then what is there in store for future for all of us, thereby challenges of EV, HEV in India way ahead for us. So to begin with my project presentation, let me begin with the types of hybrid electric vehicles. We all know, however, let me begin with that, so that I'll set the pace and then we will begin. So first is that parallel hybrid electric vehicle, wherein IC engine and electric motor both are connected to transmission. IC engine and motor are generally both are of equivalent torque and power, because they in tandem as well as individually can drive the vehicle. So accordingly, the power has to match the requirement of the vehicle. Next is series hybrid electric vehicle. Here only electric motor drives the drivetrain. Engine is not used to drive the car directly. Engine runs at a low emission and improved economy. Generally, a smaller engine is connected to the generator to power the electric motor directly, or charging the battery, and battery then drives the motor. Generally, here the battery pack is larger than the parallel electric vehicle, hybrid electric vehicle. Then there is a combined or power split hybrid, where engine as well as motor combination of various types is possible, which will drive the vehicle individually, together, or separately, and various kind of parameters can be acting together. Then there is a fuel cell hybrid electric vehicle. Fuel cell will generate the power, it will drive the vehicle, as well as it will charge the battery, and then charge battery will drive the vehicle accordingly. this kind of fuel cell vehicles, hybrid electric vehicles are also started, not yet popular enough. Another one is that category, if we call it, it's a plug-in hybrid electric vehicle. When I was working on my project, our donor, Mr. Ashok Patel, had come and then he asked me that your vehicle will need to go to a gas station for filling diesel, or any hybrid electric vehicle which is working on diesel electric or petrol electric will have to go to the gasoline station. But there may be some operators, some users who would just not want to go to the gas station. So thereby, that plug-in hybrid I came to know about. I'm talking about way back in 2012. Okay, that time HEV was hardly even talked about. Then there is the HEV onboard charging. My project, we later on tried to do that onboard charging, and we partly succeeded, but still there are a lot of work to be done. But there can be solar operated or fuel cell or IC engine operated onboard charging can be possible for all types of hybrid electric vehicles. And then there is another category of vehicles, hybrid electric vehicles, which can be in-wheel motors, that is called hub motors. So as I said, all HEVs can be used in different modes. Initially, some eyewash was being done by the manufacturers like micro hybrid, which can be, I do not know why they called it hybrid, but then that system available on those vehicles was start-stop. Whenever the vehicle is halted in traffic or at the signal for a certain amount of time, the engine will be shut off. And that is what was called as micro hybrid. And it will start again once you press the accelerator or clutch. Another hybrid, they called it mild hybrid. It was again with start-stop system as well as regenerative braking, that electric boost they call it. Next was full hybrid, where start-stop system was there, regenerative braking was there, and the charge depleting mode also was there. Whenever the charge is depleted, the vehicle will turn on into conventional fuel. And the last one, plug-in hybrid, which is start-stop as well as regenerative braking with chargeable depleting mode and rechargeable battery also. So with this, let me begin with my project, which was on reduction in consumption of fuel in existing diesel car. So the preamble on which I started working was the several causes for growing concerns those days. This project was started in 2008, and the preamble was depleting fossil fuel. There was much hue and cry about the fuel resources going to be exhausted by 2060, and that is how this depleting fossil fuel concern for everyone has started. Dependency of country's economy because of import of crude oil and global pricing of crude oil. That time and even today, OPEC countries are controlling the prices of crude oil, whereby the prices of oil, diesel and petrol keeps jumping up and down. So particularly this is called national oil security. And that is also one of the concerns. International concern for environment had begun those days due to impact of global warming and greenhouse gases emission. Limited number of cost-effective research made then in the direction of efficiency enhancement and controlled combustion parameters. Because those days, I think Euro 2, Euro 3 was going on, and I expected that something should be done or some research is necessary to convert the existing vehicles into hybrid electric vehicles. So alternate energy sources also have dependency either on oil wells or on renewable sources. But the rise in volume year on year of cells, that adds to the gravity of problem further and more. Then the important point is that replacement of all the vehicles on road to a non-polluting electric vehicle is just not attainable. And hence it is necessary to have proper solution to convert the existing vehicles into EV or hybrid electric vehicles. There are advantages and disadvantages associated with EV, HEV, but soon the necessary infrastructure will be developed by the government so that the disadvantages associated with EV, HEV will be nullified. Also, there is a need for development of innovative process and efficient methodology for conversion of millions of cars into hybrid electric vehicles. There is a problem if all these cars start getting converted, then the new vehicle sales will go down. So that is why OEMs will not be interested in this. That is what I realized later. But for reducing consumption of fuel and prevention of fossil fuel reserves for longer period and better usage in fuel, conversion of millions of vehicles available on road is the key for reducing the import bills. Once Chetan Maini in his paper concluded that important societal and economic benefits would result by implementation of EV and HEVs. So the objective of my project was reduction in consumption of fuel in existing diesel car by retrofitment of two DC hub motors directly onto the rear wheels. In a car where rear wheels are non-driven, that is non-powered rear wheels. For example, the research was conducted on a front-engine front-wheel drive vehicle with semi-trailing link suspension. So this is what was the project and objective. While the research was oriented towards conversion of existing vehicles, it can be implemented widely in all these currently manufactured as well as new models that will be introduced, because most of the vehicles on road are front engine front wheel drive and rear wheels are possible to be introduced or fitted with hub motors. If this concept is appreciated and adopted by the existing car manufacturers, a huge production of cars can add value to the corporate social responsibility and be able to compete in the market. In fact, all the vehicle manufacturers will have to compete. If one manufacturer will come out with a similar, I'm not saying the same, or similar conversion process, everybody else will have to follow. So, to compete in the market and also result in saving of foreign exchange for the country by reduction in per capita consumption of fuel. So the concern, basically where I started working on this project, major concern that I started looking at was related to two parameters, two factors. That is low speed running and high speed running. Low speed and high speed operating conditions, which I thought were consuming more fuel, as well as even if it is EV, electric, just electric vehicle, pure electric vehicle, then also at low speed, it is going to be consuming more current and more energy. So the first concern, at low speed, electric motor draws maximum current, and during stop and go conditions in the city, high torque demanding conditions are there. When you are starting off from zero speed, the high torque is required to drive the vehicle off from zero speed. And that time, maximum current is drawn by the motor from the battery. Hence, the battery storage, however large it can be, will be depleted very fast. And second point that I was concerned about, that IC engine vehicles, when it is operated for maximum acceleration or cruising or driving at high speed, the engine demands more gasoline or diesel at high engine RPM. Only if you provide more fuel, then it is going to accelerate or run at a higher speed continuously. Thus, the consumption of fuel is very high for even an IC engine vehicle or an HEV running in IC engine mode at high speed. So, under both the above conditions, it is losing proposition regarding energy utilization and transmission efficiency losses. So, the end result is what? It is limiting the range if it is pure EV or low fuel average and adding to pollution. So this proposed method, which is actually falling in purview of draft AIS 123. This draft 123, AIS 123, that time a draft for CMVR type approval of vehicles. In the morning, Dr. Tipse was talking about type approval. So any new model vehicle or retrofitment that you do, you have to go for type approval from ARAI. So this draft for electric vehicle conversion was actually complying because the increase in weight due to conversion was only 50 to 60 kg approximately. So within 5% if the curve weight, if you are doing some conversion, most of CMVR test rules, which is being done on the conversion being done on a vehicle which is already approved by ARAI, then the base vehicle is automatically implied. So you don't have to go for much of the compliance with respect to the performance of the overall vehicle, except for the mandatory requirements for the aggregates, motor and battery and electrical items, controllers that need to be approved. So the research work conducted in this study was combination of parallel hybrid. So how it was? Engine is remaining the same. I have not touched anything on the existing driveline, which is front engine, front wheel drive. And the specified gradability, acceleration, everything is retained as per normal mode. During the period when electric motors are driving the vehicle, the IC engine, the kind of conversion that I had done, IC engine is running at idling RPM because the accessories like power steering, the power steering pump, as well as the compressor for AC, water pump, and radiator fan and alternator. These accessories will need IC engine to be running. So the IC engine, even in electric mode when the vehicle is being driven, will have to be run at least at idling RPM. Okay. Why I am saying idling RPM? Because at idling it will consume the lowest fuel. The two hub motors are directly coupled to non-driving rear wheels of conventional vehicle. One each of RH and LH wheels. So two hub motors were fitted into the rear hubs, non-driving wheels. What was the testing method and routes that I had taken up? The vehicle to be converted was tested in as-is condition for different routes, which were followed for the hybrid electric mode as well. So the vehicle to be converted was tested in as-is condition for different routes with same load, the tire inflation pressure, and the same driver. So GVW remaining same, tire inflation pressure remaining same, and the driver also remaining same. This vehicle was under similar condition tested after conversion. And the same vehicle for electric mode, electric hybrid mode, and then the same vehicle was duly converted, was also tested for only IC engine, because under IC under the circumstances when the batteries are depleted and you are running the vehicle under IC engine mode, then you should know how much additional fuel that vehicle is going to consume with the 50-60 kg of additional load that one can calculate or find out. But still I had done that as well. Now, the routes that I had taken were Vidyanagar to Tarapur State Highway and Vidyanagar to Dakor State Highway. These are the two routes more or less similar. We had taken another route as expressway, and some city traffic condition driving as well. These are the pictures of right and left wheels from the rear. If you see, this is the motor, this is left wheel. The motor, the shaft is coming out of the semi-link suspension trailing link rear. Shock absorber of the existing vehicle remains same. Suspension for the rear remaining same. I had removed the brake drum and added a disc brake here. If you see this picture is very clear on the right side. There's a disc brake and the hub motor, which is fitted in place of the existing earlier shaft and the brake disc. Instead of in place of brake drum, the brake disc was fitted. If you see the vehicle complete left and right, this was the first phase of vehicle electric conversion development. Okay, at that time, the maximum power of vehicle motor that was available was only 2.5 kilowatt motor, and only one source I could identify, I could locate, wherein this was the diameter of the motor and the configuration was such that the wheels were outside the vehicle by about 200 millimeters. But later on, we went back to the same organization, same company, and developed bigger diameter motor so that the stack height of the motor increased and the power we could bring in the inner wheels, bring in the wheels which was almost about 10 millimeter outside as compared to the existing vehicle. But if you see the vehicle in the in ADIT, you will find that it is almost looking like no change. So when we tested the vehicle, there were about 30 readings that I have taken. Fuel average per trip. Okay, so that the range is 17, 18, 21 to maximum 32, 31, 32. So I could derive. I mean, we could run in city traffic conditions. These are all city traffic conditions. 1, 2, 3. 1, 2, 3, 1, 2, 3. That is how the test results are plotted. And city traffic, we could get less. You will get to know better the next slide. See, if you see the comparison of fuel average with respect to kilometers covered in a trip. So the higher the kilometers covered, means better the fuel efficiency. So lower the kilometers covered is that city area where fuel average is also low. This is another graph where fuel average with respect to average speed during the trip. If the average speed of the fuel of the vehicle was lower, between 20 to 40, the fuel average was within the range of 15, 17 to 20, 22. But as the fuel average speed was higher than 40, up to 65, the fuel average went up to 31, 32.
Hello, am I audible, sir?
Yes, please. Yes, tell me.
Sir, can you show previous slide? Means I want to just ask, on x-axis trip numbers are there, na? So at some point the efficiencies are more. So these trips, different routes are there, means locations are different, sir.
Yes.
I want to ask.
Yes.
Okay, sir.
I showed you that like the routes were 3-4 routes. One is Vidyanagar Tarapur State Highway. Other was Vidyanagar Dakor State Highway. Then expressway. The longer route that you will find is that expressway route. And then stop
Okay,
and
okay.
go. So the larger the, more the average speed, obviously the fuel average is better. This fuel, actually the consumption of fuel is only because the engine has to run on idling speed even while your vehicle is running on electric mode. Because the engine accessories like compressor, power steering pump as well as alternator has to run, or a motor, water pump has to run on that IC engine. So before that, one test that also we had conducted about the battery. Since I had that 160 mm dia, as I said, the first phase motor was 160 dia, and second phase motor that we developed was 220 millimeter dia. So that first phase of motor, when we after fitment, we found that it is going way beyond. We took those motors as well as the suspension out and put it onto a test bed into the laboratory. And that test bed is also available in ADIT even today. So on the test bed that we tested, we got the opportunity to test the battery duration for up to how much duration the battery will last, which type of battery will last, how much duration. Say like I had used a 60 ampere hour, then 100 ampere hour, 110 ampere hour battery, all lead acid of course. So that is where we got an opportunity to test this motor for 650 to 700 RPM of the motor, and we measured the time and kind of current drawn and the battery voltage drop till the time the motors will stop running. So this test data, some of the data was not recorded properly. We tested it very few times, but we could understand as to maximum up to maybe 30 minutes duration, 30, 35, and once it was 95. So about 30 to 95, it's surprising, but that is what we got. Sometimes it was only 17 millimeters, 17. It is all because of the kind of charging of battery that we did after every time that battery was depleted. Sometimes the operator would not take due care, so that is how this kind of variation was there. But we got a judgment as to if the battery is properly fully charged, we can run. This was again no load testing, okay? So when load, it will be even less. So when we compared with one of the EVs, then it was, we could understand that the kind of vehicle we had developed, that is Tata Indica, which was the curve weight was 1080 kg plus 60 kg of that additional weight. See, the additional weight that I am talking about is for we remove the brake drum and put the battery, put the motors. That is what I'm talking about. And then additionally, if you look at the batteries, that controller, then it will be additionally about 60 kg more. So the 165 by 65 R13 tires, they were kept same. Front brake was disc, no change, no modification. But rear brake was, instead of brake drum, it was disc brake, and maximum speed that I could achieve in electric mode, that was 68 kilometers per hour. But those days, whatever motor was available could be now, if you look at even higher kilowatt motors with higher max RPM are available. And if that kind of vehicles with max torque availability, if we can fit, I think we can convert millions of cars today into hybrid electric vehicle. And like the fuel, government can save on dollars, plentiful dollars. So the range we could get was 113 kilometers per charge. So actually, if you look at the factors affecting fuel consumption, right, will be like load carried per unit power of engine, then engine air induction design, fuel injection, valve arrangement, engine lubrication, engine cooling, exhaust gas treatment, and other engine management system, including air-fuel ratio as well as adjustment of various power requirements like fuel delivery during the course of running, right? And drivetrain ratios as well as body type for aerodynamic drag forces, tire properties as well as tire to road contact combination properties affecting the vehicle performance. These are all the parameters which will affect the fuel consumption, fuel average for a given vehicle. Given the set of specifications for the vehicle which was converted into EV, and earlier it was ICE running vehicle, then the major change that would happen is driver's habit along with the traffic conditions, right? But we followed the same routes, more or less same time duration, and largely responsible factors for fuel consumption were not affecting the testing that we did for ICE as well as HEV in EV mode. The same vehicle in EV mode when we tested. So the conclusion I could draw was actually, if you look at, we could achieve almost 40% with the preliminary kind of work that was done, was 40% of fuel consumption improvement we had achieved. And the conclusion was it is possible to convert majority of old cars with front engine, front wheel drive vehicles into hybrid electric cars without much of difficulty and at reasonable cost. This method of converting conventional cars into hybrid electric cars is very easy and possible to be implemented in new models as well, or which are being introduced in future by the vehicle manufacturers. The newly developed motors and shaft design provide necessary ease of conversion, because my project work, I had to buy those available motors and modify it to fit it into our vehicle configuration. And in fact, the entire motor was dismantled and so many components were changed and assembled again, which was a major task for us. And then the serviceability can be also possible easily. Barring the inherent quality of tendency of electrical and electronic components, better service life of the bearings can be ensured, because here the major problem would be the bearings, inner and outer bearings, which I had changed whatever I had got from China and modified it to use the Indian quality bearings with double ball self-aligning bearings, which would sealed for life, so no greasing required, and accordingly that serviceability part was also taken care. So coming to the second point of my presentation, I have the data of vehicle cars from 1994, which went on from 1994 2,64,000 to 574 to 15 lakh 21,000 to 19 lakh 26,000 in 2009-10. Then it went on to so many. Now 2010 onwards, I have passenger cars, commercial vehicles, and three-wheelers and two-wheelers. Now, if you look at this 2013-14, the data shows that it had little drop in 2013-14 because of global prices, global impact of government, global impact of prices, and then government scams were also there. If you remember 2014, just before the election, that probably must have affected this. But however, the total of the vehicles, number of vehicles sold, all vehicles put together, was still higher. So the progress, the growth in automobile vehicles is again and again going on for years after years. Now again in 2019, if you see, there has been growth in every year, consistently going on. As Dr. Tipse also said in the morning, the growth is inevitable. It's going to be there, like it or not. Fuel prices, again this year, that 1920, the effect of the growth was degrowth actually because of fuel prices, China crisis, Bharat stage 6. Actually, people were worried whether Bharat 4 to Bharat 6, what is going to happen if I buy the Bharat 4, I mean, like by April 20, the Bharat 4 stage 6 will be applicable. So should I go for Bharat stage 6 vehicle or buy 4? And EV dilemma was also there. What is going to happen about electric vehicles as a government policy? That is the reason why this degrowth took place. But good sign in December, this year 2020, there were about 27,000 vehicles. 27,000 electric two-wheelers were sold. Actually, three-wheelers must have been lakhs and lakhs of numbers because they were all, unregistered, and many manufacturers had mushroomed, and they have made some vehicles, electric vehicles, and sold in the market. That data is not available. Four-wheelers, passenger cars are too less to be shown. That's why none of the agencies are also giving that data. But two-wheelers, particularly in 2020, I found that 27,000, the data shows that 27,000 vehicles, two-wheelers, electric, were sold. It started long back, but the growth was not there. First time into 2020, 27,000 vehicles were sold. Similarly, if you see the December 20 data, why I am showing you all this data is because you need to understand that these many vehicles are the prospect for conversion into electric vehicles, or maybe in future all these vehicles will be electric or hybrid electric vehicles. So commercial vehicles, yes, it was 14% down. Actually, this data is for 1,272 RTOs, because they are 207 RTOs are not connected on Vahan 4, that software being used by RTOs. So it is, this data is less 207 RTOs out of total 1,477 RTOs. This is for commercial vehicles. For two-wheelers, passenger vehicles, the data I am showing is the case for less 207 RTOs out of 1,477 RTOs. So commercial vehicles we see 14% down, but Two-wheelers, it was 12% more increase. In December, I'm comparing December to December, December 20 to December 19 data. This is December 20 and this is December 19. Total number of vehicles 1273, 318. As against this year, it was 14,24,620. So there is 12% growth in two-wheelers. Passenger vehicles, it is 24%. In spite of that, if you see now currently, the present situation is that 5 lakh cars have been ordered onto the dealers, and they are in waiting because some parts may be not available because of the China crisis, or the chips are not available and the vehicles are waiting to be delivered. Again, after so many decades, that waiting period has started, and dealers' stocks have thinned down. All the dealers' stocks have reduced now. Then three-wheelers again. If you see the commercial vehicles and three-wheelers, these two products have been affected. That is, three-wheelers are 52%. Probably the passengers vehicle, three-wheeler passenger vehicles must not have been sold any because of COVID effect, because many people started traveling by own vehicles and bought two-wheelers or four-wheelers, but they did not want to go for three-wheeler passenger vehicles. That's why probably number of vehicles sold, three-wheeler vehicles sold must have gone down drastically. But again, tractors also went up. So total, however, if you see, December sale was 18,44,147, which projected can be for 2021, 2,28,000, 2 crore 28 lakhs. So coming to the next point as to what is that 2030 looking at. Now 2030, before that, if we see world over, only 2.5% was the share of electric vehicles market world over. Out of the new cars sold, 2.5% were only EV. Only 2.5% were EV. But it is projected that by 2030, the EV will go to almost 30%. By 2030, electric vehicles and hybrid vehicles will go to 30% of the new vehicles sold. Now, how will that be with respect to the countries? India is nowhere, but China is going to be the maximum growth in electric vehicle sales. Then comes Europe, and then the lowest is US. US will be lower, but global, if you look at, global will be here, and that is what is 30% that I talked about. By 2030, globally, EV will be sold in 30% of the total new vehicle sales. So, what is the consumer or users' priorities for EV adoption and their greatest concern regarding battery-powered vehicles or EV, HEV? That is driving range, maximum speed. Earlier it was, nowadays that max speed is not an issue at all. The technology has been developed. Running cost versus initial cost, initial price, that is at premium. Time required to charge. People want it with they're comparing with just like petrol pump, that 15 minutes, within 15 minutes the charging should be complete. Lack of electric charging infrastructure, safety concern with battery technology, and fear of load on grid. Government must be worried that if every vehicle, 100% all vehicles start running on electricity, then the grid will not be able to provide the required electricity. So out of this EV, what will be the HEV market share? So by 2019, that market share was only 2.4%. Okay, but again, I got the data, found out that in US by 2019, 5.4 million vehicles, Europe 3 million vehicles by 2020, and if you see that initially people thought that HEV is unnecessary due to low cost of gasoline, but later due to concern out of national oil security or better fuel economy and reduction in harmful emission, that GHG gases, importance started gaining. It is perceived that as EV and HEV is going to be core segment of future automotive market. By April 20, 17 millions of HEV were sold worldwide, and out of which the Japan is the leader, and 7.5 million were registered by March 18, at the rate of 19% of market share. We are talking about 2.5, 2.4% market share of EV, HEV. With respect to that, Japan was already at 19% market share in 2018. So to look at the government vision, Government of India had a vision, Automotive Mission Plan 2026, wherein what they say is by 2026, Indian automotive industry will be among top 3 of the world engineering manufacturing of export vehicles, auto components, and will encompass safe, efficient, environment-friendly conditions for affordable mobility of people and transportation of goods comparable with global standards. And it will be growing in value to over 12% of India's GDP and generating an additional of 65 million jobs. And how that will happen? That will happen by Atmanirbhar, Make in India and Scale India. The target Indian automotive industry will grow by 3.5 to 4 times. At 2015, it was 4,64,000 crore, which will go up to maybe optimistic 16,16,000 or 18,89,000 crores. That is what is government automotive mission plan. The same thing is depicted in different format here. So, if you look at the recent auto news, ET Auto, Economic Times Auto News, petrol diesel prices rising on 3 straight days. Value introduced integrated powertrain for 2-3-wheelers based on 48-volt technology and a cost-effective electrification of small mobility vehicles. Desi startups ride on China to make in India e-bikes. Small companies have sprung up across the country. There are a number of mushrooming today. I showed you 27,000 two-wheelers sold. It was only 29 manufacturers. But the 29 out of 29, only 15 were actually functional. So 15 vehicle manufacturing selling 27,000 vehicles. So recent auto news, once again, Britain had originally planned to ban sale of new petrol and diesel vehicles by 2040. But now it has been brought forward, and they say that by 2030, entire UK will ban petrol and diesel vehicles, and only electric or hybrid electric vehicles will be sellable. So what are the challenges? So the challenges are operational capabilities of electric vehicle have to be met with primary requirements, because compliance to CMVR we cannot escape. Compliance to IP65 for standard or IP65 standard for all electrical rotating parts mandatory, we cannot escape. Then customers' requirement will be the range, the payload, reliability, repeatability, lower cost of business. So all these customers' requirement will be also have to be met. The technology perspective, technology representative of competitive advantage only will survive and facilitate rapid uptake in future. If the companies are not update and technologically competitive, they will not survive. So as I said, out of 30, there are only 15 vehicle manufacturers which are selling two-wheelers, and only those competitive vehicles, technologically competitive vehicle manufacturers will survive. So further we go ahead. There are a number of slides on challenges. Okay, now let us go ahead with this. That power electronic component manufacturing development in India has yet to start. Thermal management of battery and electronics, battery and electricals, which is also a kind of parameter which will have to be tested, validated, and then proven. Validation through laboratory testing, on-field testing for providing life cycle of the entire system. Today we don't know how long these vehicles will survive, and that is what is the anxiety of the people, apart from the range of the vehicle in single charge. So real-time testing versus accelerated testing, this is all pending, this is all going on. Subsystem standardization for different vehicles or vehicle platform needs to be finalized. Actually, unless the vehicle manufacturer begin collaborating with each other and standardizing some of the components, some of the subsystems, they may have their own vehicle platforms and differentiator, but some of the subsystems will have to be standardized. As I said, like batteries, battery BMS controller. Controller may be sort of not possible to be standardized, but battery BMS, some wiring harnesses, some connectors, some terminals can be standardized, so that then the volume for those tier 1, tier 2 suppliers will go up, and they will get ready to supply good quality products, and the cost of the vehicles will come down. That is what they call it, a modularization of components in circuitry. like you know, many of the vehicle manufacturers, they are using common engine. Say from, for example, Fiat engine is being used on by two different OEM vehicle manufacturers, and still going on. I mean, like, it's possible. So that is what the government, industry should come closer and do the modularization of components and standardization of subsystems for making the vehicles cheaper. Also, software verification. The softwares are also available, but then software verification and validation for different modules and operational conditions is required to be tested. The prevailing government policies also will be taking little longer time for finalizing. By the time new development of certain components have taken place, the entire subsystem or vehicle system integration has changed. You will find that something has already changed, like batteries from lithium ion. Probably after maybe 5 years down the line, there will be something different available, and that the total configuration will change. So this development and verification validation process is going to be a longer time taking topic, which is a big major challenge. Reliability and because if electrical systems, there is always a question of reliability and repeatability. Its connections, circuits, electrical contact fasteners, materials for every basic electrical component. So all these parameters, all these things will have to be looked into with the perspective of the vehicle vibrations at contact points. Every contact point, the vehicle vibrations are going to create havoc. There will be losses, there will be pitting of connections, and efficiency loss will be there. Suddenly the things will break out. So the issue related to vehicle vibrations and at contact point is also a hurdle. What is important is low loss, consistent performance with high efficiency. Then low or high voltage circuit management and wires. There are some software companies, when I heard for the first time, there are software companies who are having software for designing the wire circuits, wire sizes and for the circuitry. So if 1 meter of wire, which is saving 1 meter of wire, will be huge in quantity if we are talking about maybe 4 crore vehicles. So battery, the challenge is electrolyte material availability, its quality, compatibility, low to high energy density, then variety of chemistry. For example, even lithium ion ore from different sources are going to be of different chemistry, different kind of quality, and which is what is going to create trouble for making up the same ampere hour capacity battery. The sizes of the battery is going to be different. Suppose you are using 48 volt, 12 volt battery, 48 volt system, four batteries, and tomorrow you want to replace the batteries. The battery available will be of different size. So that is going to be a different challenge to be faced in future by the customer. All these uncertainties are driving the customers away. So charging current is also another dilemma, time dilemma. How much time it is going to take for the charging? Usable life of the battery, which is again question mark, validated, but still people will have to be convinced and people have to trust and believe the manufacturers. BMS design and performance characteristics. Under the heating conditions, it is going to be really challenging. Cooling system and thermal management, CFD analysis will have to be carried out for everything, including motor, controller, BMS, everything, batteries. Then and then actual field conditions are going to be different with different operator, different driver. So these are the real challenges that we'll have to face. Inter-cell connections for pack of batteries, and under the vibration, vehicle vibration, these connections are going to actually create a lot of trouble. So managing number of cells in the battery pack. So all those things are important. Cost of battery pack, again, since the time dilemma is there, charging time, charging current and charging time, then swappable battery is also one option which people have talked about, thinking about. But even the changing of swappable batteries is an issue. There are a variety of issues with swappable batteries as well. But it will be possible only if standard battery packs are available, because from manufacturer to manufacturer, if the batteries are not same, it cannot be possible to implement swappable batteries. Then ultimately the disposal of process for the battery or recycling of the battery, disposal of battery. Electrical drive. So optimum design is important. Variety of optimum design, when I say I mean that it has to be, see, every component that goes into every vehicle, in particular electrical hybrid electric vehicle, has to be the lowest weight as best as possible, because that weight is to be carried by the vehicle battery, that energy content that is there in the battery. So optimum design for anything and everything which is more relevant in case of electric vehicle. So variety of types of motors, cost of motors, controller, and different types of motors are being tried out by different manufacturers. Because one is output performance parameters that are expected, there are variations in expectations, and cost of the motor, controller, and BMS. All these items are so costly today. Sorry. Peak torque and power. There is also concern. Low loss, high efficiency under all driving conditions is what is required to be designed. Magnetic material availability. Different types of magnetic materials are available. Again, thereby the quality of the motor will depend. Then charging related is again convenience and affordability. We talked about that. Modern technology for charging is required to be developed. There are a number of technologies we see on maybe WhatsApp and maybe another source of information. But how cost effective they are, that is to be ensured. And what customer expects, that charging to be done full charging to be available in 15 minutes, just like fuel filling at the gas station. So ultimately, the insufficient charging infrastructure is current situation. Affordability of charging infrastructure is also charging infrastructure. They are motivating people to through MSME to start the charging infrastructure. A lot of encouragement and help is being given by the government, but it should be affordable because the number of vehicles, the volumes are not there. So that it's a chicken and egg situation. The volume will go up, then the charging infrastructure will improve, or if charging infrastructure will improve, then only volume will go up. So government is trying their own best way. Initial cost, sorry, initial cost is a deterrent. Subsystem cost versus demand. That positive business case doesn't happen here as of today. Quicker development. The development time is again going to incur a lot of cost. So the development has to be very quick. Standard components and system architecture, hardwares. That is what I talked about. Flexible software. Flexible software we can like modify and implement. Say for example BMS or controllers. If we have software possibility of modifying the software and implement it for different types of vehicle, different manufacturers vehicle with the same BMS, then probably it will become cheaper because the volumes will go up, all vehicles put together. Platform with different product differentiation. With flexible software, hardware components, the platform with different product differentiation can be possible. And that is where the scalability will come into picture. So leverage, optimize resources. This is important. All these things are important to leverage and optimize the resources available. Different manufacturers will have different capabilities, different kind of resources, which can be utilized for other manufacturers as well. Utilization of assets also will help. The range, challenge of range, small vehicles versus large distances. And so conflicting requirements are there. Daily charging is inconvenient for the customers. Consumer demand that the charging, one charge vehicle should be able to go more than 400 miles. As good as a petrol tank full, you go for almost 700, 600, 700 kilometers. That is what is expected out of EV, HEV as well. So combination of convenience, affordability, and there is an opportunity. So the other challenges are industry roadmap to be ready. It should be ready by now, so that because all are waiting for infrastructure to be developed by the government, infrastructure to be coming up by those people for charging on the way, highway as well as interior roads. So then the roadmap for the industry, probably they must be ready with the vehicles to manufacture. So compatibility of assembly line, actually I do not know how far this has been developed, but there should be a compatibility of assembly line processes for EV as well as conventional vehicles. On the same line, they should be able to make both the types of vehicles. Subsystem of vehicle integration and aggregating, the gap should be reduced. There is a skill gap, as I say. The particular system integration, our individuals, the college students, they are good at subsystem level. They have the knowledge, but when it comes to integration of the systems, that know-how and know-why, which is missing. That is where the industry always says there is a skill gap required to available from the engineering students that are graduating. Focus on localization, vocal for local, and Atmanirbhar. These are the things that are important. Now, testing facilities, equipments are getting fully established. I'll just finish in another 10 minutes, okay? So, Yagnesh, is it okay? Hello?
Yes,
Yeah,
sir.
yes.
Yeah. So, testing facilities and equipments getting fully established, yet getting established. Exploring alternate materials for high energy density batteries for enhanced life is important. That is also being done. Power supply sufficiency, load on grid, which is also there. So that is why probably you will see that the government of India is setting up huge energy parks. One of them coming in Bhuj, that is 30 gigawatt hybrid energy park coming up in Bhuj. So once that kind of energy is available, which is locally available and locally consumed, this kind of EV and HEV charging will not have any difficulties, according to me. So regenerative braking is so-called e-boost for great driving experience and engine idling, auto start stop system. These are all the systems that actually when they're there in some of the vehicles, I'm always worried as to what about the additional cost because of this kind of system that they are introduced, and how much percentage of saving of fuel that is providing. I have a doubt. I do not know if somebody has made a study. This is kind of thing that is cost versus benefit. One has to work out and whether it is necessary as of today, according to me. And risk of short circuiting due to water ingress. EV, HEV, there is always a problem as to because our tropical country, many of the places we get flooding, and if the electric vehicles have short circuiting because of water ingress, then there is a problem. Because in proper sealing for all mechanical component will be always deficient because whatever best way manufactured, the seals will leak. So what about that? And uncontrolled, the drivers will be uncontrollable. They will always do the best of their ability to raise the vehicles, and overheating of components will take place. The and electrical junction will get heated, the connections will get damaged, and drivers will not even bother. So the vehicles, electric vehicles, will be prone to damage faster otherwise. This is not enough. The projected sales volumes are low. That is what we saw. That 30% among so many 30 manufacturers. So that scalability will be very difficult. Scalable volumes not reached yet. It is difficult to reach, and profitability is a dream as of today. That is why. That is why the reason. That is the reason why tier 1 and tier 2 suppliers are facing difficulties, because everything cannot be manufactured by the OEM manufacturers. Tier 1, tier 2 suppliers also must be ready to develop the required component as fast as possible. So EV growth requires actually the battery. When I come to battery, there is a problem of lithium ion ore processing to packaging to OEM to end customer, and that is where the cost of lithium ion battery is very high, because the source of lithium ion is somewhere, the processing is done somewhere else, then the battery is being supplied to different countries, and then the OEM users, and then end customer. So the process chain is so long that this battery is very expensive. And that is where one has to control. And then quality of lithium ion ore also varies from different source, different size of packaging I mentioned. But I understand there are different varieties of battery manufacturing is being developed, researched, and they say that breakthrough technology of sodium ion for high energy density, long life batteries at cheaper cost with sustainable resources is awaited to hit the market very soon. So the good sign, as government is also supporting, If you look at government incentives, government is doing RTO free, taxation free for the OEM, insurance free, or something like that. And that is why 30% of EV market share is going to be achieved by 2030. Probably income tax rebate for the OEM manufacturers also will be there. But with respect to the climate change, Paris Agreement of climate change, our country has agreed, and we have decided to cut GHG emission by 33 to 35% by 2030. Energy security, the government import of oil, which is almost to 82%, which commitment to generate to diminish the effect of this import of oil. The government is committed to generate 40% of energy through renewable sources. And the rapid urbanization, if you look at about 14 out of 20 most populated cities in the world are from India. Okay, out of 20 most populated cities in the world, 14 are from our country, India. So that is why there is a stress on energy and transportation in our country. But by 2040, 77%, it is expected, projected that 77% of buses, 65% of two-wheelers, 85% of three-wheelers, 40% of passenger cars are projected to be electrified, and light and heavy commercial vehicles, maybe by 40, some marginal improvement will be there. This is what is being shown here. So what are the EV key challenges for resolution lies in software simulation. See, most of these challenges that we talked about can be possible to be eradicated or resolved through software simulation. Because software will help design cycle time reduction for billions of miles of testing on road for ensuring performance, safety, and cost. Fundamentally, as a vehicle, what is important is we have to ensure the performance, we have to ensure safety, and we have to see that the cost reduction is taking place from wherever we are existing today. So the critical areas in development of EV and HEV are electrical machines, power electronics and control systems, battery and battery management systems. So power integration, these is all combined together. So optimization of verification and validation plan, that is what is possible through software simulation. So challenges for electrical machines, how can we solve this through software simulation is it will provide the data and info as to whatever changes that you do, how can you increase the efficiency, higher thermal reliability can be achieved, how can you achieve the reduced noise, reduce size and weight. As I said, every component that goes into EV or HEV has to be a smaller size, and obviously if the size is smaller, the weight also will be low. Better system efficiency and conflicting requirements of performance, packaging, cost, manufacturability, vehicle system integration, advanced magnetics, torque, speed, efficiency, thermal analysis, all this can be, for the electrical machines, can be addressed through software being developed for this. Then the challenges for power electronics, that is switching frequency, over voltage and thermal reliability for the same power electronic systems, system optimization, meeting the standards. When you are developing the software, you need to comply with ISO 26262 and power electronic component. The cost though today, as of today, is very high. The life of this component is expected to be 10 years. Similarly, battery and BMS, the range expected is 400 miles, as I said earlier, charging 15 minutes only, and life 10 years. Actually, this 10 years now, people will start looking at 20 years because the government has started looking at 20 years of scrapping policy. As of today, it is voluntary, but later on, people will start looking at 20 years life of a vehicle that they buy. So similarly, high energy density batteries associated with thermal reliability then able to withstand structural abuse. This battery, since the dead weight battery dead is like a dead weight onto the vehicle, and with the kind of road vibration because of road surface in undulations, this is actually under abuse. All the connectors and the battery box control systems. So that is where is a big challenge, which probably may be addressed by software simulation. So these are my references. CM Alternate Fuel by TIPSE, TERI, Ministry of Road Transport, Automotive Mission Plan, National Electric Mobility Mission Plan, then ANSYS, KPIT. I sincerely thank Professor Yagnesh Gambava, Professor Baladat, Dr. Sanjay Patel, Dr. YD Patel, Dr. Vishal Singh, top management of CVM, this FDP organizing team, and all the participants. Thank you very much. I hope you enjoyed, and I still have some time for questions if anybody has. Thank you very much.
Thank you, sir. Now I would like to ask participants to raise their queries.
All well. Everybody is tired.
Okay, sir. So with this, I would like to thank you for your wonderful presentation on hybrid electric vehicle. And it is every time a pleasure to interact with you.
Thank you very much.
Thank you so much for the insight you have provided. And on behalf of A.D. Patel Institute of Technology and Automobile and Mechanical Engineering Department, I thank you. Thank you for sparing your valuable time.
Any of the participants interested in converting or developing some better hybrid electric vehicles can get in touch with me. I will be interested in working with them, along with them, because it's a national issue. National, OEMs, as I said, will not be interested, but maybe some startup can think of developing some kit for converting. Email ID.
Yes, sir. Please share your mail ID in the chat section so that participants can get in touch with you.
I hope it was all okay. No disturbance this time today. Today, no disturbance, no issue, no bandwidth problem, right?
Yes, sir. So someone profile name Patel classes have shown interest, and I hope because you have given your mail ID, so
Yes.
I hope he might have noted it, and of course go ahead with the work. So thank you so much, sir, for your presentation and for your time.
Thank you. Thank you. Good day. Good day, all of you.